Okay, so now you know how to write type 1 binary ionic compounds. Now we're going to do type 2. So type 2 binary ionic compounds. Now, I want you to take your periodic table and I want you to look at it. And let me erase some of these marks that are on here. And I want you to take a highlighter. I want you to take something like a highlighter or a colored pencil. And I want you to find the elements that have more than one charge. Kind of like germanium. The metals, I should say, the metals with more than one charge. And thallium, and vanadium, and chromium, manganese. I want you to highlight them. So next time you look at your periodic table, you can immediately tell these are what we call type 2 metals. So we look at all of them. I don't think I missed any. If I did, I'll come back and look. But I think that's all my type 2 metals up there. We can do down here too if you'd like. But we typically never use these, so if it makes you feel better, I'll highlight those as well. Okay, here we go. So I've highlighted my metals that have more than one charge. Like copper has a +1 and a +2 charge. Manganese has a +2, +3, +4, +6, or +7 charge. So we definitely highlight those. Those are our type 2 metals. So type 2 metals, the metal has more than one possible charge. Not that the charge is more than one, but it's got more than one possible charge. Binary again means there's only 2 elements in the compound. Ionic means it's a metal plus a non-metal. Notice the metal always comes first. The metal is always written first, no matter what. M before N. Okay, so you can write that down. So you want to make sure you have out your periodic table and your flow chart while you're trying to do these. Okay, so let us work with type 2 binary ionic compounds. So first let's write formulas for them. So now when you do type 2 compounds, because they have more than one possible charge, like copper, Cu, has a 1 and a 2. It's got more than one possible charge. You have to tell the reader which charge you're going to be using. If you're using the 1, you have to write it copper and in Roman numerals 1 in parentheses. If it's the copper 2 you're using, you use copper in parentheses 2. If you don't know your Roman numerals, here they are: 1, 2, 3, 4, 5, 6, 7, 8. These are my commas down here. So 1, 2, 3, 4, 5, 6, 7, and 8. And those are the Roman numerals we'll be using. The Roman numerals tell you which of these 2 charges, or any of the charges, we'll be using. You've got to tell the reader which charge you're using. It's as simple as that. Okay, so if I said you have iron 3 chloride, again IDE because it's binary, the first thing you do is write down your symbols. Iron symbol is Fe. Chlorine symbol is Cl. Then we write down our charges. Well, iron has a charge of 2 and 3. Which one did I use? I've used the 3. So that's the charge I write down, plus 3. I look at chlorine on the periodic table, and chlorine only has a -1 charge. So I put a -1 there. I do what I did last time. I crisscross my charges. This 3 comes down there. This 1 comes down there. And my formula is FeCl3. Pretty simple, huh? Writing formulas should be no problem. You just write down the symbols and write down the charges. Let's try another one. Let's say I have, I'll look these things up actually. Manganese, six, V1 for 6, nitride, IDE. Nitrogen goes to nitride. Write down my symbols. Manganese is Mn. Nitrogen is an N. Now, which charge did I use for manganese? Manganese can be 2, 3, 4, 6, and 7. Goodness. So I use the 6. That's what goes here, plus 6. Nitrogen has a -3 charge. I look at my periodic table to find this out. And it's kind of nice because the anions only have one possible charge. There's never a question about their charges because there's only one possible. Then I do what I told you to do before. You crisscross your charges. That 6 comes down there. That 3 comes over here. And your formula is going to be MN3N6. Isn't that fun? But what can I do with that formula? Can I reduce it? Yep. I divide both sides by 3. And I get MNN2. So I get a 1:2 ratio. So I can write MnN2. That's my formula for manganese 6 nitride. Make sense? I hope so. Let me do one more and see if you can do it. Give you a minute to try it. And of course you can stop this at any point in time and take notes and things like that. So how about if I have chromium, what is wrong with you? Chromium, get it backwards there, chromium, let's see, 3, let's see, carbide, how fun is that? Now, since carbon is the second element, it's going to take on the negative charge. So we write down the symbol for chromium, Cr, and the symbol for carbon is C. My charge for chromium is right here in these parentheses, and it goes right there. And carbon is a plus or minus 4, so it takes on the -4 because it's the second element. And then you crisscross your charges. That 3 comes over here. That 4 comes down there. And voila, you get a formula of Cr4C3.